Hi, everybody. This is September 11th and September 14th of our astronomy unit. So today we're going to go through everything that we're going to be doing in Google Classroom. So you can see here we have our daily warm-up and agenda. We then are going to do a galaxy sort. If you were in class, you have some takeaways from a Pear Deck. Then we're going to watch a video over the electromagnetic spectrum. And then we're going to do some notes in Pear Deck, which we do have takeaways for um, here on the different types of electromagnetic waves. And I'll talk a little bit longer in this video about them. And then you do have some homework today where we're going to do everyday radiation slide examples with what you have at home that uses electromagnetic waves. Next week on Thursday for A Day and Friday for B Day, we do have our first astronomy test, and so you also have your astronomy study guide. So for our daily warm-up and attendance, it tells you to scroll to the top to complete that. It looks a little different today. I'm trying a new process. So we'll click here for our daily warm-up. We have our warm-up slide. And our warm-up asks which star is most like our sun. Is it 1, 2, 3, or 4? So here's the spectral class with some stars shown, 1, 2, 3, or 4. Gives you the letters. We should know that our sun is a main sequence star with a luminosity of 1. So when you go to 1 and you see where it intersects main sequence, that's going to make our star right here. So with that, if I go down, that is spectral class of G. So I want to go see if these stars have a spectral class of G, and yes, number 3 does. If it were a number M, it would have to be over here, and we know we're not a supergiant or a giant or a red dwarf. Over here, we'd be way up high, and we're not. We're not these blue giants. A would be right about here, and that's a little too bright on the brightness scale and way too hot. So we need to know that our sun lies about right here in the middle. Okay, so what you need to do now is you need to go back to your Google Classroom, and you would click on your attendance and you fill in your attendance and you would put your answer in for your warm-up to get credit for that, because I am going to take a warm-up grade every 2 weeks, which would be 5 days, so it's 20 points per warm-up. So you're going to want to make sure that you get that completed. Okay, after we've done our warm-up, let's go back and look. I just want to review, and I reviewed everyone when you did your interactive notebook over galaxies and light years. I talked about how light years is a measure of distance when we talk about space, because space is so big that we need to have a way to not have such big numbers. If you were dealing with miles, kilometers, the numbers would just be too big. So you have a data table here, and you had to drag these little tags over, and it's like a number line saying that this is 8 light years from the sun out here, and so you have to estimate where these would go. So Barnard's star is 4.9 light years. So Barnard's star would just be past the 4. That's about 4.9. Lumon 16 is 6.59. So you just have to estimate where that would be. The Earth is 8.4 light minutes. So think about the speed of light traveling for 8 minutes. It wouldn't get very far. So we'd be really close to the sun. Pluto is 5.5 light hours. So that's going to be farther away, but still pretty close to the sun. And then Sirius A is 8.58 light years. So our table went to 8, so you need to go beyond that. So this would be a way to model light years. And we need light years because our distances in space are so huge. Here's a rendering of what they think the Milky Way looks like. Remember, we're part of the Milky Way, so we don't have an arm long enough to go out and take a selfie to see what our galaxy looks like. So scientists have to plot the stars of like where they are and how they move to predict that they move like a spiral galaxy. So there's over 200 billion stars in our galaxy, and our galaxy is 100,000 light years across. So think about this. That means one star on one side takes 100,000 years for light to get all the way across that galaxy, traveling at the speed of light, which is super fast. That's like going 350,000 kilometers in 1 second. You've ran an 800 twice around the football field. 2 times around the football field is 1 kilometer. So if it go 350,000 times around that in 1 second. So when you're looking up at the night sky and you see a star, that light is very old. The closest star to us besides our sun is a little over 4 light years away. So that light is 4 years old. It's been traveling through space for 4 years before we see it. Most other stars that we see at night, or even galaxies, are millions of light years away. Another common misconception is that people think that our sun is in the middle of our galaxy, and it's not. The middle of our galaxy here is simply made of really old dying stars, which are your red giants. Our star, which I have right here, is in one of these outer bands, and one of the arms, we call it, of these spiral galaxies. So know that we're not in the center. The interactive notebook also talked about how, excuse me, that scientists classify these millions of galaxies by their shape. And so you need to know the name of the galaxy and the description. So spiral galaxies will have a shape that have a dense center and then these arms that spiral around because it moves in a circle. So I do want to show you this little model that I like to use in class, a paper plate to show the dense center and the fact that if this galaxy were spinning, it makes the spiral arms. But sometimes we're of the perspective that we look like this in the galaxy. And when that's the case, we're looking back towards all this clump or line of stars towards the center. So it can still be a spiral, but it's about perspective and where we are in the universe. So that can still be a spiral galaxy. Our elliptical galaxy, those simply look like balls, like a football or a softball. They're oval shaped. They are the most abundant type of galaxy in the universe. Most are composed of old low mass stars, which would be your red giants and red supergiants. So they're just going to be like a glowing circle. And then you have irregular galaxies. They don't have any defined shape. It's not a ball. It's not like a pinwheel shape. And these are usually left over from two galaxies that have collided, and then everything is just kind of in disarray. So that is what we went over in class. Know that as we are getting ready to have our test, that this was our pay attention to list, that you guys actually in your journal took vocabulary over these terms from our STEMscopedia reading. So you're going to want to go back and use STEMscopedia and study this vocabulary. In here you have your different 3 different types of galaxies. So that's going to be important to know. Today we're going to focus on that electromagnetic spectrum. So I'm going to go now, and let's go back to Google Classroom. We did a galaxy sort in Pear Deck, and in our galaxy sort, I'm going to see if one of these opens up with the Pear Deck. A lot of the people got takeaways from these, so if you have your takeaway, I'm just going to show you what that looks like because you were not here. Gives you the opportunity to summarize the lesson, and I actually had pictures, and you were actually going to circle those answers. So let me see if I can make it bigger. You had to circle in different colors, which ones were irregular, which ones were elliptical, and which ones were spiral. And this would have been our correct answer. So you get to take a look at that. Okay, so now we're going to go back, and you're going to need to watch this video on the electromagnetic spectrum. It kind of gives you some background information. And then we did a Pear Deck over and took Cornell notes in our journal. So you're going to need to add electromagnetic spectrum. Let me make this larger. Electromagnetic spectrum to your table of contents. And then electromagnetic spectrum is actually still part of our astronomy unit. So you've got your astronomy triangle fold. You have your PAT list. You're going to go over and you're going to put your terms from this notes page that we have in there. So I'm going to put these notes in there for you to be able to look at. So let's come back here now, and you'll need to read through that electromagnetic wave notes. Those that were in class actually had takeaways with their answers. And then the last thing you'll need to do is, for homework, you have a slide here, everyday electromagnetic waves. So you're going to go and you're going to give me, do a quick search. You can use the video to help you. Give 5 devices that you have around your house that use different types of electromagnetic waves. And you would tell me the type of wave and the function for that device. And you'll be surprised at how many of those that you have around. And then last but not least, I have a couple of songs that could help you. And again, make sure you read these instructions because it will tell you to come back up because this video has a lot of examples as well. And then last but not least, we have our astronomy study guide, which you have your own copy. So you can use any of your notes that we've done in our astronomy unit to help you answer this. I do ask that with your answers, you take and do change the color of your font so that your answers are in a different color. So that slide and your review sheet will be due by next class period, which will either be next Tuesday or next Wednesday. So I hope that this covers everything that you have there. Don't forget, I have tutoring at 8 a.m. in the mornings and then at 2:15 every afternoon. Bye-bye.